Okay, so we're on Journal 49, and so for bell work today, I'll be having you guys solve for x, and notice that they're both exponents here, and so you have a base to an exponent of x, and so that exponent is our variable, so we have to get that x, we have to figure out what that x value is. So, like with the first one here, it's saying 10 to some power gives you 100. Well, if we think about it, it doesn't take too long to figure it out, but 10 squared, or 10 times 10, equals 100, right? So in this case, x must be 2. So in this case, x is equal to 2. So we're trying to find the exponent here that makes the other side true. So like this one here is a little bit tricky. Notice you have a 1/4, so we have to figure out what power does make this 1/4 turn into a 4. Well, we learned when we have negative exponents, so when I have 4 to the negative 1 power, that makes it, actually let me write it this way. So I'm going to erase that real quick. So if I have 1/4 to the negative 1 power, remember, the negative power makes the fraction flip. In other words, this turns into 4 over 1. Well, 4 over 1 is just 4, right? So in this case, x is equal to negative 1. So in that case, x is equal to negative 1. So today what we're going to be doing is solving for x, but our x is going to be the exponent. And so we're going to figure out how we can do that. So let's take a look at our first slide. Okay, so with these problems here, what we have to do is solve for the equation. So that means I have to get x by itself, or sometimes n, whatever the variable is. And in order to do that, you have to make sure that the bases are first the same. So if you take a look at these problems, like A here, notice that this base here is A2, and this one here is a base of 8, right? They're completely different bases. So what do we do when the bases are not the same? Well, we try to force them to be the same. And one way you can do this is by looking at these two bases, asking yourself which one is bigger. So it looks like the 8's bigger. So it's easier to take a bigger number and try to make it the same base as a smaller one. So what I mean is, like this 8, we can write 8 as a base of 2, right? Because if you think about it, how many 2's do you have to multiply to make 8? Well, 2 to the third power, or 2 times 2 gives you 4, and then you multiply by another 2. Well, 4 times 2 gives you 8. I just multiplied 2 3 times. So this is why it's 2 to the third power. So I'm replacing this 8 with 2 to the third power. And then the other side's already a 2, so I'm just going to drag it down the way it is. So just 2x comes down. And look, the bases are the same. So we learned last week, if the bases are the same, they cancel, right? And so that means their exponents drop down, and there's an equal sign between them, so x is equal to 3. Well, if x is equal to 3, we're done because x is by itself. So here is my answer. So the key to this is to try to make or force both sides to have the same base. So like with this one here, you have a 4 and you have a 64, right? So just looking at the bases here, this is a 4 and this is a 64. Well, I'm going to try to make the bigger number, the 64, to be the same base as this side. So how can I make 64 with a base of 4? Well, let's think about it. 4 to the what power gives me 64? So if you try to multiply 4, let's figure out how many times to multiply 4 to give you 64. Well, 4 times 4 gives you 16. 16 times 4 gives you 64. I multiplied 4 3 times there. So it looks like 4 to the third power gives you 64. If you don't believe me, just grab out a calculator and multiply 4 3 times. Okay, 4 to the other side here is 4 to the 2n minus 1. I'm going to just drop that down because that's already a base of 4. And since now their bases are both 4's, they cancel. And so I just have 2n minus 1 equals 3. And so now I have to get this n by itself, so maybe add 1 to both sides. That would cancel on this side. And so I have 2n equals 3 plus 1 gives me 4. And to get rid of that 2 on the end, I'm going to divide by 2. So that cancels. So n is equal to, let's see, 4 divided by 2 gives me 2. And so n is equal to 2. All right, let's try out part C. So C here, we have a base of, let's grab a highlighter, a base of 9 and a base of 3. Now, 9 is the bigger number, so let's think, how many 3's do I need to multiply to get me 9? Well, 3 times 3 gives me 9, so that's 2 3's right there. So if I do 3, oops, my bad. Let me grab a pen. 3 squared, or 3 to the second power, that's going to give me 9. However, there's more stuff here next to the 9, right? There's a 2x minus 1. So that means that I need to add on that exponent. And so I'm going to wrap this around with parentheses and write that 2x minus 1 in the exponent. So this used to be the 9, but now it's replaced with 3 squared. And then I'm just putting parentheses around it so that I can add on that exponent. And then the other side's already a 3, so I'm going to drop that down as 3 6x. And so the reason why I put around parentheses around this 3 is because I noticed that there's an exponent on the inside and the outside. So we learned that if you have an exponent on the inside and outside, you have to multiply the two exponents. So in this case, there are two terms here, a 2x and a minus 1. So I have to make sure I distribute this 2 to the 2x and to the 1. So let me draw some arrows to show that I'm distributing. And so in this case, this is going to be 3. 2 times 2x is 4x. 2 times negative 1 is negative 2 equals 3 6x. Now the bases are now the same, so they cancel. And now I have 4x minus 2 equals 6x. And so now I need to get this x by itself, so maybe subtract the 4x on both sides. That cancels, so I have negative 2 equals 6x minus 4x is 2x. If I divide by 2 to get rid of the 2 on the x, that's going to make x equal negative 2 divided by 2 gives you negative 1. And I have x by itself. Okay, that wasn't too bad. Let's try D. So D, you'll notice one side is a 1 and the other side is a 4. Well, okay, typically we would try to change this bigger number to have the same base of 1, but unfortunately 1 to any power is still 1, right? Because if you multiply 1 by itself, it's always going to be 1. So this is a very special case. So anytime you have 1, you can actually change that 1 to any base you like. So this base is a 4, right? I can change this 1 to a base of 4. Here's how I do it. So if I decide that this side is 4, my exponent has to be 0. Because let's think about it. Any base to a power of 0, whenever the power is 0, that means that the value is 1. So anything to 0 power is 1, right? So that's why whenever you have 1, you could choose whatever base you like as long as it's to the 0 power. So I chose 4 because I want to cancel out with this side here. So I'm going to drop this part down. So we have 4, 3x minus 2. And now that the bases are the same, they cancel. And so I have 3x minus 2 equals 0. So now I'm going to try to get this x by itself. I'm going to add 2 to both sides. That cancels. I now have 3x equals 2. So I'm going to try to get rid of that 3, divide by 3 on each side. So x is equal to 2 over 3. And boom, I have my x by itself, so I've solved for x. All right, let's do a few more example problems, and then this should really help you out with page 1 on the packet 11. Okay, so to kind of give you guys a little bit more variety here, like part A, notice that this one's a fraction, and this one is a a 5, a whole number. So just like the bell work, you might have remembered that 1 over 5, I can also write it as 5 to the -1 power, because all that does is make my 5 put in the denominator. So instead of it being 5, this would be 1 over 5. So in this case, I can rewrite this guy 1 over 5 as 5 to the -1 power. Well, there's still stuff outside of the this base here, so I need to make sure I bring that down. So I'm going to bring that down as x plus 2, and then I'm going to bring down the other stuff. This one's a 5, 3x. So the reason why I chose 5 as my base is because the other side was already 5, so I saw the advantage there. Now, there's an exponent in the inside and there's an exponent outside. So we learned a moment ago, or just as a fresh reminder. So 2 properties that we utilize here when we're solving for an equation is, one, if you have an exponent on the inside and you have an exponent on the outside of the parentheses, you multiply. And then we'll talk about the second property here in a sec, but I'll kind of hold that off until we need it. So here, I need to distribute this -1 to the x and to the 2. So this is going to be 5 negative x minus 2 equals 5 3x. The bases are both the same, so they cancel. And so now I have negative x minus 2 equals 3x. So perhaps maybe adding this x to both sides, so that way we can try to get all the x's together. So these cancel. -2 is left on the left-hand side. 3 plus 1x gives me 4x. To get rid of this 4, I need to divide by 4. 4's cancel. So -2 divided by 4 gives me -1/2 equals x. And now x is by itself. Okay, so with that one there, anytime you have like 1 over a number, feel free to use that base, so the 5, and just raise it to the -1 power, because that's how it got in the denominator, is because it was a -1 as a power. So this one here, notice that you have all 7 as your bases, which is great. So we know that the base here is going to be 7. However, this side, there are 2 7s here, right? So anytime you have 2 of the 2 bases that are the same, what do you do with the exponents when you multiply them? Well, if you remember, one of the properties that we learned in the first semester is when you multiply bases that are the same, or multiply x's with x, and this x has an exponent and this also has an exponent, then you add the exponent. So that's exactly what we're going to do here. We're going to add the 5x with the -2x. And if I combine them, I'm going to have 7, grab a pen here, 5x plus -2x is going to be 3x. So if I add those 2 exponents, I get 3x. And notice that I didn't multiply, I don't multiply the 7s, I just drag one copy of the 7 down. So you don't multiply the numbers, just bring the number down and then add the exponents when you're multiplying. This side here is already a 7 6x, so that's great because it gets to cancel on both sides because the bases are both the same. So now I'm left with 3x equals 6x. Okay, you want to make sure you try to get all the x's on one side. So here's what I'm going to do. I'm going to subtract 3x to both sides. So that cancels. So if everything on the left-hand side cancels, that means I just have 0 left on the left-hand side. And on the right-hand side, 6x minus 3x is going to give me 3x. And so I just need to divide by 3 to get rid of this 3. And if I divide this side by 3, well, okay. 0 divided by 3 is going to be 0. Anything divided by 0 is going to be 0. So whenever the numerator here is like a 0, it's always going to be 0. So x is equal to 0. Okay. 2 problems left. So let's take a look at C. So C here, you'll notice that you have quite a bit of things going on. You have this coefficient that's in front of this exponent, right? 7 to some power. So what we have to do when there's a constant here being multiplied and is not the same base, then we have to try to see if we can make this constant have the same base as 7. Well, if we think about it, 49 is really just 7 squared, right? 7 times 7 gives me 49. So I can change that 49 to 7 squared. And then I'm going to bring down everything else. So 7 negative x plus 2 equals 7 3x. Now, just a moment ago, we said that whenever the bases are the same and you're multiplying, we add the bases. So here's what's going to happen. 7, if I add 2 with negative x plus 2, now you don't have to show this work, but I am going to. This 2 will be added with this 2 if I combine like terms, right? And so this is going to be 7, 4. Now there's a negative x here, so I'm going to make sure I bring that down. So negative x equals 7, 3x. Okay? So now I just have the 7s to deal with, so they cancel because they're both the same. So I have 4 minus x equals 3x. So maybe I'll add this x to this side. That side will cancel. So I have 4 equals 3x plus 1x gives me 4x. So now in this case, let me see if I can zoom this out a little bit. Yeah, there we go. So if I divide by 4 on both sides, 4's cancel. So x is equal to 4 divided by 4, which is 1. And x by itself. Okay. Let's take a look at D, our last problem here. So for D, notice that all the bases are different. So I'm going to highlight all the bases. Here's a 4, a 2, and a 16. So out of these three, you're going to pick a base that will work with all three of them. So for me, I can see that 4 can be composed of 2, right? 2 squared gives you 4. So I have to ask myself, okay, can 16 be decomposed as a base of 2? And actually I can. So I'm going to show you that here in a sec, but let me change the 4 here. So 4 can be written as 2 squared, but there are exponents outside of the 4, so that I need to drag that down. So I have x minus 1 on the outside. There's a multiplication sign after, so I'm going to drag that down. And then it's 2, 3x. So I'm going to drag that down because it's already a base of 2. I don't have to mess with it. So I'm not going to. And then the 16. So how many times do you multiply 2 to get 16? Well, 2 times 2 gives you 4. 4 times 2 gives you 8. So I'm up to 3 2's here. And if I multiply 8 by another 2, that's 16. So in this case, it looks like I multiplied 2. Let me grab a green pen. 2 to the 4th power will give me 16. And so this is raised to the 5th power because there's a 5 after the 16. Okay, so now what we're going to do is we're going to try to clean things up just a little bit. So like perhaps multiply the exponents. So remember, we're distributing exponents. So this 2 gets multiplied to the x and the negative 1. So this is 2x minus 2. And then this one here, we have a 3x equals 2. There is a 4 and a 5, so I'm going to multiply that. So that's 2 to the 20th power. And so now I have 2 2's on this side, and they're being multiplied, so the bases are the same, so I'm going to add the exponents. So in this case, it's going to be 2x minus 2 plus 3x equals 2 to the 20th power. So if I add the exponents here, if I combine like terms, you'll notice that the 2x and the 3x will combine nicely, right? So that would make it 2 to the 5x minus 2 drops down equals 2 to the 20th. So the 2's cancel because the bases are the same on both sides. So I really just have 5x minus 2 equals 20. And now I'm going to just try to get x by itself. So maybe add 2 to both sides. That cancels. I'm going to need more room. So now I have 5x equals 22. Now I'm going to try to get this x by itself by dividing 5 to both sides. X's cancel. So, I'm sorry, not x's cancel, 5's cancel, and x is equal to 22 over 5, or if you want to write that as a decimal, you're more than welcome to. But I'll just keep my answer as a fraction. And that's it for this journal.